Our class will be on what we call descriptive statistics and also data presentation. So this is one of the easiest topics, but very risky topics because it's time consuming. So I'm going to look at what is called group data and ungrouped data combined. So you'll be given a question like this, but A, you'll be asked to draw a stem and leaf diagram. Now, a stem and leaf diagram is drawn as follows. So we have our stem this side and our leaves this side. So the stem are simply the first figures that we have. So we have numbers that start with the 0, the 1s, the 2s, and the 3s. We also have numbers that start with 4s, the 40s. So we need to arrange them in order, starting from the smallest. So 0, 1.
Are you writing that somewhere? I can't see anything.
Are you able to see what I'm writing, the rest of you?
Yes.
Yes.
Yes, I can see.
So we have 0, 1, then we have 0, 3. Then the next number is what? 11, which is 1, 1. What's the next number? Another 11. Then on the ones, we also 15.
15.
And on the twos, we have what? The smallest is 20, so 2, 0. Then 23, 2, 3. Then 24, 2, 4. Then 25, 2, 5. On the 30s, we have the smallest is what? 3, 0. Then followed by what?
3, 1. 3, 1.
On the 40s,
Yeah.
42.
4, 2.
So total numbers we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our n is what? 12. Okay, maybe I can add, do I add some more? Maybe we have 26, then we have, and we have 41 or 40, 43. Okay, so 2, 6, where does 2, 6 go? 2, 6 is here. And we have 33 there. Or let me make it 3, 1 here. So we have 3, 1. So 31, another 31 there. Then we have 4, 3, which is 43. So our n that we have here, what becomes our n? Our n is 15. So this is what we call the stem and leaf diagram. Now, we are both revising and learning at this time. So I want you please to not embarrass me by trying what you're able to. So from the stem and leaf diagram, help me identify the range. What is our range? Who can tell us what the range is?
We are to subtract the the largest minus the lowest value.
So the highest value minus what? The lowest value. What is our highest value?
It's 43.
The lowest value
is 0, 1.
0, 1. And what becomes our range?
Range, that should be 42.
Then what becomes our mid-range? Mid-range is what? Half of the range. So what is half of 42? 21. All right. Then anyone who wants to give us any measures of central tendency or dispersion? What is our mode? Who can tell us what the mode stands for?
Most frequent number.
Frequent number.
Yeah, the most.
Which one is the most frequent number?
Eleven.
11. Do you agree with him?
Yes.
11, that's all. How about this one here?
And 31.
31.
31.
31.
11. 1. by mode of. All right. So we also want to identify what we call the quartiles. So we have 3 quartiles. Can somebody tell us the 3 quartiles that we have?
The first quartile,
Which is Q1. It's given by a quarter of n plus 1. Then which other quartile do we have? So our n is 15, meaning our n plus 1 is what? If our n is 15, what is our n plus 1?
16.
So meaning the quarter of 16 is what?
16.
The quarter of 16 is what? The 4th number.
4.
So let's count the 4th number. 1, 2, 3, 4. What number is this?
11.
11, correct. So 11.
So how did you count again?
1, 2, 3, 4. Since they are arranged in order, so the 4th number is what you pick. So this is the 11th number. The 4th number, sorry, which is 11. So 4 is a position, not the answer. 4 is a position, it's not the answer. Then we also have the second quartile. The second quartile is also called the median. It is half of n plus 1. And our n plus 1 we established is 16. What is half of 16?
8.
8 is a position, but not the answer. So let's count which one is the 8th position. 1, 2, 3, 5, 6, 7, 8. So what number is this?
24.
Okay, it's not a 4, but a what? A 24, right? So our 8th position is 24, correct? Then we have the other quartile. What's the name of the other quartile?
Third quarter.
The 3rd quartile is denoted as Q3. So this is 3 quarters of n plus 1. Our n plus 1 is 16. So what is 3 quarters of 16?
12.
Which one is the 12th position?
31.
31.
So this is 8, 9, 10, 11, 12. So this is 31. Anyone behind on the quartiles?
Me, I'm behind Mr. Collins. Sorry, I joined in a bit late. Just a quick browse through.
Okay, so we established the stem and leaf diagram by rearranging these in ascending order. So if you have a number like 102, you get the 10, which is your stem, and the 2 will be the leaf. The last number is simply the leaf. But since we have a 2-digit number of 01, so 01, 03, then here we have 11, so 11, 11, 15. So we are arranging them in the order. So 30 is 30, 42 is 42. So 43 cannot come before 42, so we arrange them in order. After that, we identify the range as being the highest number minus the smallest number. 43 minus 1 is what? 42. Then half of the 42 is called the mid-range, which is 21. And the number that appears the most is called the mode. So we have these ones together. Don't count the ones that are significantly many here, no. The ones that are consecutively many here. So if we had 5, 5, 5, so the 15 could have been the mode. So look at the most appearing. Then we went to the quartiles. We have 3 quartiles. The first quartile is a quarter. So a quarter of n plus 1, our n plus 1 is 16. So a quarter of 16 is the 4th number. When you count 1, 2, 3, 4, the 4th number is 11. When you count the second quarter, this is half of 16, which is the 8th number. When you count up to here, the 8th number is 4, but the stem is a 2, so this is 24. Then the third quarter is also, when you count there, you're going to get this number, which is what? Our 31. So quartiles also have a range. The range is called the interquartile range. And the interquartile range is simply the difference between the highest quartile and the lowest quartile. So IQR is the initial that we use. The interquartile range is simply quartile 3 minus quartile 1. Then the semi-quartile deviation or the semi-quartile range is simply half of what? interquartile range. Then we also have what we call the correction term, which is the CT. The correction term is simply 1.5 times IQR, okay, or simply 3/2 IQR. This is called the correction term. So with this being given, how do we find the interquartile range?
We rub the 1.5.
The same, 1.5 or 3/2.
Okay.
You love the 1.5? All right. So since we've established that the interquartile range is what? Q3 minus what? Q1. Since our Q3 was what? Was
81.
31 minus 11, what do we get?
20.
20. Then we go to the semi-quartile deviation, simply half of the interquartile range. So here, half of the 20, get the what? 10.
10.
Then we also go to the correction term. Correction term is 1.5 times interquartile range. So 1.5 times 20, what do we get? 1.5 times 20, we get that. So this correction term lets us find the lower bound and the upper bound. The lower bound is simply Q1 minus correction term. Upper bound is simply Q3 plus correction term. So our Q1 was what? 11. So 11 minus 30, that is our lower bound. The upper bound is 31. 31 plus 30 is the what are we getting here? Here we're going to get 61, and here we're going to get what? What is 11 minus
19.
negative 19? So this has come up with what is called a box Descrptive. A box Descrptive has 5 elements. Okay. So we have 3, in fact 5 important things there. We have the minimum value of x, value of x. We have Q1, Q2, Q3. All right. So what is our minimum value of x? Our minimum value of x is what? 0, 1, and the maximum was 43. So when we put the 0, 1, 0, 1 is here, and here 43. Then the first quarter, Q1 was 11, 24, and 31. 11, 24, and 31. Then we identify the lower bound, negative 19 and 61. Where's negative 19? Negative 19 is where? Somewhere here. And positive 61 is somewhere here. So these ones are the extreme values. So if all these figures are within the extreme values, it means we have no outlier. An outlier is simply a number that is outside the feasible region. So with that being said, there is no outlier. we have done data presentation of this question. Now I want to do the ungroup data of this presentation. Now, since these figures are many, I can just use smaller figures just to illustrate what I'm talking about. You have numbers like 1, 2, 3, 4, 5. Okay, so if we have 1, 3, 3, 5, 6. Okay, can somebody tell me which one is our mode here?
3.
3. Which one is our median?
3.
For what? N plus 1. Our N is what? 1, 2, 3, 4, 5. What is our N plus 1?
6.
What is that for?
3.
What is the third number?
3.
3.
3. Okay. So this is our median. Right, then we go to something else. The summation of x is when we add these numbers. Then when we square each one of these ones, we have what? What do we have here when you square this part? 1 squared is 1. 3 squared, what do we have? 3 squared here, 9. 5 squared,
5. 25.
squared,
36. 36.
what we get, add them for the summation of x squared. Okay. So what we get when we add up here?
70.
Is 70. Then on top,
18.
18. So can somebody tell me, how do we find the mean?
Summation of x squared divided by n.
Summation x over n. Right. So what is the summation of x there? 18. And what is our n? 5.
5.
What becomes our mean?
3.6.
3.6. Okay. Then we have the variance. How do we find the variance? Variance is denoted by the symbol x squared. So it is given by summation of x squared and a summation of x over n minus 1. Can somebody give us what is summation of x squared? 70.
70.
7.
18 squared. Now n, 5. Everything over
5.
5 minus 1. The starting point is always this part here. 18 squared divided by 5 is
So, Mr. Collins, what's the difference with the summation of x squared, which is in brackets, and the one without brackets?
all right. What's the difference is the question?
You follow the BODMAS there. I think you follow strictly the BODMAS rule there that the x, I mean the x squared should be, if it's bracketed, you're not going to get the summation of the x squared.
Exactly. And that's the one mistake people make here. Sometimes here they put what? 70. Then here where the summation of x squared, they put 70 again. This is summation of x in brackets, the power 2. So this is the power 2. But this one, summation of x without the brackets, it means we are squaring the individual units. Okay. Is that clear?
Okay.
Are we following? Is anyone behind? Okay, I was only supposed to take 20 minutes on this one here because it's just, and by the way, everyone is expected to know this topic. The summation of x to the power 2 over n, so 18 squared over 5, 64.8. You subtract it from 70, you get 5.2. 5 minus 1 is 4. When you divide that, you get 1.3. This is called our sample variance. So if s squared is equal to 1.3, then our standard deviation is simply the square root of the variance. Square root of 1.3, what does it give you? 1.3 square root will give you 1.1.
1.14.
And we also have what we call the coefficient of variation, which is a CV, given by the standard deviation over the mean times 100. It measures
You
the
said the S on top means what?
standard deviation, S. S means what? Standard deviation. And S squared means what?
Variance.
Variance, yes. Okay, so here we're going to have 1.14 divided by the mean which we had. Our mean was what? 3.6.
3.6.
So when you multiply this by 100, you're going to get that 1.7%. And finally, is what we call the coefficient of variation. The coefficient of variation. And the coefficient of variation is simply 3 mean minus what? Median over standard deviation. The 3 is part of the formula. So our mean, we've already established is 3.6. Our median was 3, and our standard deviation we found as what? 1.14. So when you compute that, 3.6 minus 3 times 3 divided by 1.14, it will give you positive 1.57. So here you're only interested in a positive answer or a negative answer. Your comment, if it's a positive, it means it's what? Skewed to the right, or it's positively skewed. So this is a positive skewness, means chuffing in upper right, it's positive or to the right. If the distribution is skewed to the left, it means maybe most people have failed here, or the distribution is what? Skewed to the left. The weight is spelled like that. So it's called coefficient of skewness. If you get 0, it means it is what? Normally it's distributed. Yes, Matimba.
I didn't get what you said on the coefficients of the variation.
So coefficient of variation
How you got that?
is given by the standard deviation, which was 1.14, divided by the mean. The mean, we just calculated it here. Our mean was 3.6. So when you divide our standard deviation, which is 1.14, the mean is 3.6 multiplied times 100, we get our percentage as at 1.7. That is how.
Yes, and then the next thing there.
The next thing is called coefficient of variation.
Yes,
How do you find the
that.
variation? It is 3 mean minus the standard deviation. Our 3 is
So
part
that's the formula. The 3 comes with the formula.
yes, the 3 comes the formula, yes.
Oh, okay.
So there's a difference between the two coefficient of variations.
Yes, there's coefficient of variation of skewness. Sorry, this is what skewness.
Oh, okay.
Kind of skewness. Yeah. All right. Then later on, you'd be told from this same data we had here, to come up with what? To convert it to grouped data. Firstly, you'll be asked to draw what is called a histogram. So first of all, we can summarize these ranges as follows. Number one, the numbers that start from 0 to 9, how many are they? 0 to 9, how many are they?
There are two.
There are 2. Okay. Then we have we'll convert them into classes. So we have the classes as follows: 0 to 9, we have 10 to 19, we have 20 to 29, we have 80 to 39, and we have 40 to 39. So how many do we have? 0 to 9, we have 2. Then 10 to 19, we have 3. Okay. 3. Then this one we had 20, then we had what? 23, we had 24.
20 and 24. There are 3.
We had 25 as well. Then also had 26, right? I think I wrapped those ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, yes. So the 2s, 1, 2, 3, 4, 5. The 3s, 1, 2, 3, 3.
3.
The 4s, yeah.
2.
So we've come up with what we call grouped data. Right? Are we together? So now we can use this group data now to come up with what is called, okay, even before I wrap this, you can even come up with what we call a histogram. So we have established here that the classes are given as follows. Go to 9, 10 to 19. We also have what? 22, 9, 32, 39, 42, 49. So we are going to have what? 2, 3, 5, 3, and 2. This is what the frequency column. We will have what is called the cumulative frequency. How do we come up with the cumulative frequency column? We start with the 2 there. We add it to the 3. What do we get? 2, we add it to the 3, we get 5. And 5, we add it to the 5, what we get?
10,
10 to the 3, what we get?
13,
13 to the 2, what we get?
15,
Should tally with the final answer that we get here, which is our 15, which stands for the N. Then relative frequency, we're simply dividing 2 divided by 15, 3 divided by 15. So we're dividing everything by the total. Relative means subject the total. So 2 divided by 15, we're going to get 0.13. How about 3 divided by 15? We're going to get 0.2. And 5 divided by 15, we're going to get what?
3.
0. What? 3. And 3 divided by 15, 0.2. And 2 divided by 15, 0.13. Right. Then the relative cumulative frequency, we keep adding the way we're doing. We start with 0.13. Then we add a 2 there, we get 0.33. We add that one, we get 0.66. Add that one there, we get 0.86. We add that one, the final answer must be 1 or 100%. Now, when you're going to draw your histogram, The stem-leaf diagram
Sorry,
give you
the
an
relative frequency we're dividing cumulative frequency with 15.
the relative, we're dividing the total into each of these ones here. 2,
Okay.
15, 15, etc. Okay. Then for this one here, you can divide 15 into each of these ones. 15 over 15, 1. 15 into 13, this. 15 into 10, that. 15 into 5, that. 15 into 2, you get that. Or you keep adding. This 0.13, you put it there, you add it to this. Then 0.
The last one where we got 0.3, we
Ah.
divided which one and which one?
Can I repeat that?
5 divided by 15. It's not.
It's 0.13. You just didn't write the one there.
Which one?
No.
The last one where you have 0.3, you divided which one?
Which 0.3?
Divided 2.
And the relative frequency.
So let me go through again.
Frequency.
2 divided by 15, we get 0.13. 3 divided by 15, 0.2. 5 divided by 15, 0.33. 3 divided by 15, 0.2. 2 divided by 15, 0.13.
Okay.
Yeah. Then again, we start here. 2 divided by 15, 0.13. 5 divided by 15, 0.33. 10 divided by 15, 0.66. 13 divided by 15, 0.86 or 87 if you want. 15 divided by 15, you get 1.00. All together? So if you're going to tilt this upside down, you'll see that the histogram will look something like this. We have 2 here, and we have what? 2, 3, 4, 5. We have 2 here. We have what? 3 here. We have what? 5 there. We have what? 3 there. We have what? 2 there. It will look something like this. When you tilt this one upside down, I'm just giving you a picture that the stem and leaf diagram also gives a picture of how your histogram will look like. So let's go now to draw the histogram. In fact, your figures are not adjusted like we have here. We have 0 to what? We have 0 to 9.
Mr. Collins, which figures are we using for the horizontal axis?
So let me explain that. And here we have 20 to 29, 30 to 39, we have 40 to 49. Now these ones have a lag of 1. There's a 1 in between these diagonals. So whenever you see that, you need to adjust these classes by subtracting a 0.5. So here you're going to have a negative 0.5 to what? 9.5. And here you're going to have 9.5. Here you subtract a 0.5, here you add a 0.5 to 19.5. Here we have 19.5 to what? 29.5. Here we have 29.5 to what? 39.5. Here we have 39.5 to what? 49.5. And the classes that we had of the frequencies were what? What are the classes of the frequencies? Classes of the frequencies was 23532. 23532. So this is all you need to draw a histogram. So here we are starting from what? 0.5 to 9.5. Then we have, just consider these numbers in the L. 19.5, 29.5. Then we have what? 39.5 and 49.5. So what is the height for this one? 0.5 to 9.5, it's a 2. 1, 2, 3, 4, 5, 6. You can draw your own scale depending on what you've been given. So here we have what? We have a 2. Next, what do we have? So what you can see there is simply 0.5 to 9.5, 9.5 to 19.5. So we're just using these figures there against the frequencies there. So you also put your title there as histogram. Right. So this is how you draw the histogram. Then now finally we find the mean and our median, the mode and the median. Any questions? Yes, Matimba?
Sorry to take you back. On the 0.5, I just wanted to find out how we were coming up with these figures on the classes that we've used on the histogram.
Which
Or
class?
subtracting 0.5 from each and adding 0.5 from the upper side.
So
Come again?
from each of the lower bounds here, we subtracted 0.5. It's a rule.
No. All right.
0.5. So that this diagonal, this number, and this number must be the same. This is what only qualifies you to have a histogram.
Okay.
And on these numbers, you add a 0.5. It's a rule.
All right. Thank you.
Right. Okay, so I'm going to give you some work to do. Maybe let me continue by doing the mean, the mode and the median. So for the mode and the median, I'll just use my own figures, 1 to 5. Okay, 3 to 3 to 6, 7 to 10, 11 to 14, 15 to 19. So if we have the frequency here, 4, 8, 10, 3. Okay. We have a 4 there. So how do you find the cumulative frequency? Can somebody remind us? Add to 8, 12, add to 10. What do we get? 22.
22.
Add to 4.
26. 26.
So meaning our n here is also 26. Then we need to identify the mode. What is the formula for the mode? The simplest formula is what? L plus D1 over D1 plus D2 times the height. The height is simply the difference between the intervals here. So our height here is what? 4. You can pick any randomly interval here from here to here. From here to here, it's supposed to be 18. From here to here is 4. From here to here is 4. It's supposed to be the same throughout. 4, 4, 4, 4. So our height is 4. Step 1. Step 2, how do you identify the delta 1 or the D1? Identify the highest number in the frequency. What is our highest number? 10. You can put FM there. The distance above, F1 and F2 there.
Sorry, on which one is the height?
The height is this one here, 4. The distance.
The difference.
Yes.
Okay. Then the D1 and D2.
D1 and D2, the distance between this one going up, that is our D1. The distance here and there, that is our D2. Any other questions?
Then the distance between 4 and 8 in the same frequency column.
We don't need this part. The key part is identifying the highest number first. Then the distance,
Okay.
the highest number upwards is D1. From the highest number downwards, it's D2. So if 18 was this one here, this would have been our FM. The distance 1 is there up, the distance 2 is there down there. So our D1 here is what? 2, and our D2 here is 6. Do we get that?
Then the L.
The lower
Can you
bound
explain that again?
is so we use our T formula here. First thing, identify the highest number. You put FM. Then the number above it is F1. The number below it is F2. Then using the FM, you go to the classes. The lower boundary is your L. So let's do the identification here. All right. So if our class and the frequency here we had what? 15 to 20, 20 to 25, 25 to 30, 30 to 35. And here we had 1, 7, 18, 10. Which one is our FM?
18.
18,
Our F1?
11,
7. And our F2?
8.
The numbers you're saying are not even there.
Why not 7 and 10?
Yes, F1 is 7, F2 is 10. Then the lower boundary, 25. So which one is our D1? 11. D2, 8. The distance upwards here is 11. The distance downwards here is our what? Oh, I think that's what she was getting. She went a step ahead of us. All right. All right. So this is what I was trying to do. Step 1, identify the highest. There are 10.
Mod previously, I think when we were beginning, mod was the most appearing number. So how come here we have a formula for mod?
So here, this is group data. What we're dealing at first was ungroup data. For group data, you identify the highest frequency, which is what? 10. Then you look for the number above it. So don't go, say because 4 is appearing the most, big 4. No, no, no. This is group data. So identify the highest number, it's 10. The distance above is D1. The distance below is D2. So our D1 is 2, and our D2 is 4. So our lower boundary, when you go here, it is 11. But 11 is not adjusted. So our L is
Our D2, I think it's 6, not 4.
oh, 6, thank you. Our L is supposed to be 11, but it's not adjusted. We remove a 0.5 there. Our L is 10.5.
So, Mr. Collins,
Do 6 again.
is it always that on FM, that's where we find our lower bound?
Yes, on FM. It's always on the FM.
Always on the FM.
Exactly. So here we're going to have 10.5. We're going to have 2 over 2 plus 4, the height of 4. So here we're going to have 10.5 plus 2 over 6 is 4.
Now this D2, the 6 on the table,
It's just a mistake. It's supposed to be 6, not 4, Mr. Collins. 2 plus 6, not 2 plus 4.
8. Thank you for that. So here we're going to have 8 over 8, which is 1. So we're going to have 10.5 as the final answer. This is our mod.
The D2 on the diagram on the table is which one?
The distance below here, FM and F1. Otherwise, the long formula that you would otherwise use is this one. I'm trying to simplify your work, but it seems it is failing me. So maybe you can use this after identifying that. FM minus F1 minus F2 times height. So our L is 11, but we subtract 0.5, it becomes 10.5. Our FM is 10, so here we put, where does FM, we put what? 10. F1 is 8, here you put times what? Minus F1, which is 8, minus F2, which is 4. And the height, we put our 4. Our bound, you get 10.5. If you multiply all this to get the same answer. This is the formula that we use. So I've done both group data and ungrouped data. So I'll give you some work based on that. This topic is very long, unfortunately. It takes a lot of time. So it becomes elusive to rush you through if you have not done much of your homework. Any questions?
Yes, Mr. Collins.
Yes, yes.
Sorry, I joined in a little bit late. I don't know if you had the topics in the beginning.
What do you mean you can add the topics in the beginning?
I'm saying maybe you, I'm just thinking that maybe you had a list of the scope
Yes.
of topics to concentrate on.
Okay. So the list of topics for you to clear this exam are only 4: statistics, ANOVA, regression, and hypothesis testing. So these are the topics that I want to concentrate on, especially in this 11th hour period. I'm going to meet you thrice by Monday. I'm meeting you for 2 weeks. I'm going to meet you about 4 times. I'm going to finish these topics. Ideally, I'm supposed to do 1 topic, but I want to be doing as many so that I repeat them over and over. When I come to Lusaka, we'll do 4 key topics, and all of you are going to clear unless you just want to fail. None of you is going to fail because the questions that are coming are known. So we're going to concentrate on only 4 topics for those ones that are weak. Or
You said statistics, regression, ANOVA, and which one?
And regression. Statistics, regression, ANOVA, and hypothesis testing. This one helps you avoid probability. Okay, so I will end here for now. Unless I